No-till research pioneers Lloyd Murdock and Jim Herbek reflect on their work at the Princeton Research and Education Center.
When you do traditional tillage, and basically we started with a moldboard plow, and then in Kentucky, and then we advanced to some extent to a chisel plow and a disc. Anytime you do that, either one of those, basically you increase the organic matter decomposition, which releases nutrients, which releases nitrogen, and in the short term, actually, it's a pretty neat thing and works pretty well. The only problem is that you are deteriorating the soil. You're breaking down the soil structure, you're losing organic matter, which helps maintain the soil structure, and you're losing nutrients, and the biggest part is you're losing soil, you're losing sustainability. When no-till came in and weed control came in, those were both looked extremely progressive. I mean, people were precautionary about adopting them, but they were progressive.
In 1961, my dad went with a group of farmers to an experiment station in Dixon Springs, Illinois. Dr. McKibben at Dixon Springs had a number of test plots. One of those test plots was a small one, about the size of a car, that showed crops that had been planted with no tillage. They didn't call it no tillage, they just knew that there was no plowing and no disking, and had been planted directly into the sod, and the weeds had been killed chemically. So that fall, my dad thought about it and thought, I think I can do that. So he came back and put together his own planter, and in 1962, the spring of 1962, he planted what, as far as we know, is the very first field of no-till corn here at Herndon.
And using weed control was fantastic. It changed everything. It changed the fact that you had to till. It changed the fact that you could cover large acreages in a short period of time rather than having a small cultivator and all the things that went wrong with that.
Soil specialist Dr. Lloyd Murdock of the University of Kentucky says a new device clears debris from the no-till plant row.
And it pulls or just simply rakes the trash to the side of the row about 10 inches wide, and you plant in between that 10-inch width. It allows the soil to warm up quicker in the springtime to dry out these soils that aren't well adapted. And from the measurements we made that we're just beginning here at the Princeton to research this particular technique, kind of interesting. The temperatures in the spring are somewhat close to conventional tillage, not up to what conventional tillage is, but definitely higher than no tillage. And we feel like this gives that plant a little bit quicker time to get started. It allows it to get those root systems down that it needs to get down early, and also allows the soil to dry out and a little air exchange to take place that we usually don't have sometimes in no tillage on these soils that aren't well adapted. And it was invented by Howard Martin here in Kentucky, and it's being adapted nationwide. It's two wheels that are kind of intermeshed, and they push the straw, the residue to the side, and you set them so that you just barely have the teeth in the ground so that you're just pushing the residue to the side, and it leaves it pretty clean.
And so no-till is one of the greatest discoveries in agriculture that we've ever had. There's hybrid seed corn, nitrogen fertilizer, there's some really big ones, but no-till is in there with one of the top 5, I think.
Jim Herbek worked extensively on double crop soybeans and no-till wheat.
Lloyd and I were talking, and we says, okay, we got this system of corn, then we plant wheat, and we were generally tilling the wheat, and then we'd come back and no-till double crop the soybeans. So we had one system in there that we weren't continuous no-till, so to speak. So he says, why can't we fill in this blank here of wheat between the corn and double crop soybeans? It'll be a continuous no-till rotation. We started doing a lot of research on it, and there was a few pioneer farmers that really wanted to go with this.
We started planting no-till wheat in 1983 and have planted ever since.
I guess my question is it increasing the yield?
If we could speed up double cropping, planting the soybeans earlier, this would gain some of that yield potential we've lost because of planting date. If we could gain 3, 4, 5, 6 days, just those, that would be almost a 5% increase in yield potential. And of course, no-till had come into Kentucky for several years, but this is one aspect where no-till wasn't being utilized a lot at that time yet. And taking care of the corn stalk residue, which you'd be planting into, how to manage that and so forth. So a lot of this work was done here. A lot of skepticism at first when we were working on it, but thoroughly convinced that as more and more got into it. And showing that it could work, large part of our acreage now is no-till wheat, particularly here in West Kentucky.
Some of the things that also made a difference was nitrogen. The use of nitrogen and how to use it without losing it in no-tillage, because you could lose a lot of nitrogen in no-tillage because of excessive wetness sometimes on these wet soils occurs. And then just volatilization by placing the nitrogen on the surface, which was commonly done at that time. And a lot of that work was done here, but you take the University of Kentucky as a whole, we did a tremendous amount of work to overcome that problem, to change the way things were done. That was an important step in no-tillage and making it work and making it accepted. And a lot of people were concerned about compaction, that no-tillage, never tilling, it was going to be a compaction problem. We pretty well proved that that wasn't a problem. And so there were a lot of advances. Things worked out and understood and made no-till so much more acceptable.
The Kentucky Small Grain Growers, the Kentucky Corn Growers, and the Kentucky Soybean Board all contributed to Murdock and Herbek's research over the years.
Then on top of that too, looked at best varieties to use for double crop soybeans. As far as row spacing on these late planted beans, I pushed to go to narrow rows, and that was a big boost in boosting our yields about 10-15% going with narrow rows and so forth. So it was a very opportune thing to work on at that time, and that the farmers really wanted to work on, and it satisfied me to work on that particular research. And the people I worked with here was unbelievable. We had an interaction among us here because we had hard times to overcome. We didn't have anything handed to us to do our research or do our informational meetings, but we overcame the challenges and the hard work, and it made us work together. We interacted longer. That challenge and that hardship made us a better person.
As you add organic matter, which is dead tissue and decomposing tissue, to the surface of the soil, as you do with no-till, then consequently you add a lot of food, so to speak, an energy source for all kinds of biological organisms below the surface soil. And it can be bacteria, it can be fungi. It is bacteria, it is fungi, it is earthworms, it is thrips, it's all these things. And I mean, we're talking hundreds of different types of materials that all work together to break down the large pieces of organic matter to the small pieces of organic matter, to exude the waxes and resins out of them that binds the soil together, to make it so that you have the pores that water runs through, that the soils holds together. And as you add organic matter and increase the organisms in the soil and increase the amount of carbon in the soil, you actually increase the productivity of the soil. Basically, what it boils down to is if you have the intelligence, you have the desire, and you really want to get an answer for people that mean something to you, that's important to you to get an answer for, you'll figure out how to do it. And we figured out well enough that they wanted to build us a building. And then we got more information and we got more help. And we did that well enough before they wanted to build another building for us. And so, yeah, I'm proud. I'm thankful for the opportunity that I stayed here in adversity with the other good specialists that I had, and we accomplished things that we didn't know that we could accomplish. There's never been a set of people that worked in better teamwork in the university system than these people at Princeton in the 1970s and 80s and 90s. And because of that, we accomplished a lot.
These no-till pioneers helped inspire a new generation of young farmers like Alex Young and Robert James.
And it is really amazing how such a small thing as not working your soil and letting it wash away impacts the whole environment. And so to be part of that, not just to have a grandfather that helped pioneer it, but to take part in it, to use it on the farm, is really an awesome opportunity.
Here we are in Fayette County. It's May 8th and we are planting no-plow corn. I think we're always learning. You think about the advances in crop genetics and production techniques from, the 60s on until today. The advent of the soil health system, which we've basically adopted all the tenets of that. It's amazing what we didn't know 10 years ago, and think about what we'll know 10 years from now. It's pretty exciting.
Had it not been for the vision and courage of farmers, pioneering researchers, and grain groups, no-tillage might have remained only a vision on less than an acre in Herndon, Kentucky. However, today's reality in the U.S. is that no-till is practiced on over 100 million acres.
But it's got its start here in Kentucky, which I said the state of Kentucky is the father of no-till.